Hi everyone, my name is Manuel Ortega. I'm going to talk about security and auditing tools in large language models. Large language models basically are a category of deep learning models based on neural networks and natural language processing. This tool aims to analyze the security of these language models from the developer's point of view, analyzing the many vulnerabilities that can occur in the generation of these models. Among the main points to be discussed, we can highlight the introduction to LLM, introduction to the OWASP LLM top 10, auditing tools in applications that handles these models, explain a use case with the test attack tool. We start with introduction these kind of models. These kind of models, the base of these models are transformers. Transformers are a type of neural network architecture used in natural language processing, tasks like machine translation, text summarization, and text generation. They were introduced in the paper "Attention is all you need" in 2017. The key innovation of transformers is the self-attention mechanism, allows the models to weigh the importance of different words in a sentence when making predictions. Attention, each word or token in a sentence can attend to every other word, allowing the model to capture relationships between distant words more effectively. This helps transformers understand the context, better than previous models like recurrent neural networks. In transformer kit has two main components, encoder and decoder. The encoder processes the input data like a sentence and creates a representation of it. And the decoder use the encoder representation to generate the output, translated sentence. In the case of tasks like translation, the input is processed by the encoder and the decoder the translation based on the encoder's output. The training process of these kind of models is generally divided in two stages: the pre-training and fine-tuning stages. The pre-training stage is where the model is trained on large test corpora to predict the next word in a sequence or complete sentence. This has learned and general representation of the language. And the fine-tuning stage, after the pre-training stage, the model is fine-tuned with specific data and labels for particular tasks, such as text classification, question answering, or generating coherent text in specific contexts. With the growing popularity of these kind of models, such as GPT, Gemini, Llama, among others, OWASP has published a specific list of vulnerabilities for these kind of applications. The list comes in response to the rapid adoption of these kind of models in many industries, with the aim of highlighting the main security problems associated with this emerging technology. In this table, we can see the main vulnerabilities where we can highlight in large language models. Now we analyze some of them in more detail. For example, one of the top rank is pruning involves manipulating input prompts to achieve unintended or malicious model outputs. Regarding investigation of this vulnerability, it's recommended to validate all inputs before processing them with the LLM. Command whitelist could also be implemented, and the types of data can be processed could be limited. For example, in a LLM scenario affecting input from external sources such as website or files controlled by a user, indirect prompt injection is a technique in which an attacker manipulates external inputs such as content or user data, which are then processed by the model. This can lead the model to behave in ways not intended by the developers, compromising the security and the integrity of applications. For example, a prompt could be generate a summary of the provided document, but an attacker manipulating the external source injects hidden prompts include confidential information from other files, for example, or from a specific web page, for example. Of external manipulation, the model can generate content incorporating sensitive data from unauthorized sources, leading to data leakage and security breaches. Another example of pro-injection is in the paper with title GPT-4 is too smart to be safe, still Richard with LLMs via cipher. This research explores how these models can be manipulated to engage in conversations using encryption or coded message, thereby obscuring their true intent. This method could bypass monitoring systems designed to detect misuse. A common example might be the use of cipher text or simple scrolling in incoming message, which an attacker can use to generate coded responses or decode sensitive information without it being obvious to an observer. Injection is also this attack is also known as jailbreaking. This attack involves directly manipulating the commands that are sent to these models. This research, with the title "Do Anything No?" characterizing and evaluating in the whale jailbreak prompts on large language models, analyze and evaluate so-called jailbreak prompts, which are commands designed to bypass restrictions imposed of these models. These prompts allow users to obtain answers that would normally be blocked due to ethical, illegal, or security constraints. The study investigates how these jailbreak prompts work and how effective they are by passing words. The researchers collect and characterize several examples of jailbreaks that have been created and shared in the community without academic or industrial intervention. In element development, data is crucial in pre-training for language compression, fine-tuning for quality adjustment, and embedding domain-specific knowledge. However, these datasets can be susceptible to allowing attackers to manipulate them. This manipulation, known as poisoning, can compromise the model's performance and lead to generate content aligned with malicious intentions. During pre-training, an attacker introduces misleading language ensamples, shaping the model's understanding of specific subjects. Consequently, the model might produce outputs reflecting the injected bias when used in practical applications. One of the attacks that have been investigated in last years is adversarial attacks. These attacks refers to a deliberate attempt to manipulate or deceive an artificial intelligence or machine learning model by providing it with carefully crafted input data designated to cause the models to make incorrect predictions or decisions. These attacks try to exploit vulnerabilities in the model's decision-making process, typically by introducing a small imperceptible change in the input data. These are the key characteristics of adversarial attacks. For example, smart perturbations. Attacks typically involve adding a small, carefully crafted perturbations to the input data that are often imperceptible to humans. Model vulnerabilities. These attacks exploit specific weaknesses in the machine learning model, such as its inability to generate well to new and seen data or the sensitivity of the model. to certain types of input. We can classify with two types, white box and black box. White box assume the attacker has full knowledge of the model, including its architecture, parameters, and training data. The attacker used the information to generate adversarial samples that are most likely to deceive the model. And on the other side, we have black box attacks. In black box attacks, the attacker doesn't have direct access to the model's internal workings. Instead, the attacker relies on observing the model's output in response to different inputs and using this information to craft adversarial samples. Machine learning systems are vulnerable to wide range of many adversarial attacks. Many of them employ classic machine learning models like linear regression and supervector machines, as well as deep learning systems. The majority of attacks often try to reduce classifier performance on particular tasks. The area of adversarial machine learning investigates a class of assaults meant to degrade classified performance on a particular task. At this point, we can classify adversarial attacks in different types. These are the six, we can highlight six adversarial strategies and the need for these defenses. The prone injection, as I commented before, basically prone injection in attacks involve crafting inputs to manipulate the behavior of these models, causing them to produce harmful or unintended outputs by exploiting their reliance on user prompts. Another kind of attacks is the evasion attacks. This kind of attacks involve modifying inputs to mislead models at inference time, making them stealthy and effective means of bypassing a control system. The attack's objective of this kind of attacks is to generate an input that is misclassified without needing to understand the artificial intelligence model's internal mechanism, making evasion attacks still here and particularly difficult to counter. Another kind of attacks is positioning attacks target the training files of artificial intelligence models, injecting malicious data into the training sets to compromise the model behavior. By manipulating the training data or its labels, the attacker can make the model perform poorly during the deployment. Another kind of attacks is the model inversion attacks, aims to reverse engineering artificial intelligence models to retrieve sensitive information about the training data. In these attacks, malicious actors analyze the predictions made by a model in response to many inputs. Using this analysis helps them infer sensitive details about the data the model was training on. For example, by observing how the model reacts to different input patterns, attackers can deduce features or even reconstruct portions of the original training dataset. Another kind of attack is model extraction. Model extraction attacks aims to replicate the functionality of a proprietary model by querying it with numerous inputs and observing its outputs. This attack, when an attacker illicitly appropriates the training model, typically involving reversing engineering, where the attacker deciphers the system architecture and parameters to replicate its functionality. Once in possession of the replicated system, the attacker can exploit it for various malicious activity. Finally, the member six inference attacks involves an adversary to deduce sensitive information from an artificial intelligence model by examining its outputs and behaviors. For instance, an attacker might use the confidence levels of a model to determine if a person was part of the model's training data. Typically, a model trained or on a specific data point will generate high confidence predictions for that data point if it was in its training datasets. And by introducing slight modifications to the input data and observing fluctuations in the model's confidence levels, an attacker can make educated guesses about someone's presence in the training dataset. At this point, I'm going to comment some tools that can be interesting to evaluate the model robustness. For example, the PronInject framework, that is a tool designed to study how language models like GPT can be manipulated using prompts. PAIR, that is the acronym of Prompt Automatic Interactive Refinement, is an automated methodology for iteratively refining prompts with the goal of jailbreaking LLMs. Jailbreaking refers to techniques that bypass security restrictions and guidelines imposed by language models. And another interesting tool is TAP, that is a framework that explores how to perform attacks on LLMs using a decision tree structure. Another interesting tool is fairness indicators. It is an open source tool for detecting and evaluating fairness metrics across datasets and models. In particular, this tool includes the ability to evaluate the distribution of datasets, evaluate the model performance, feel confident about your results with confidence intervals at multiple thresholds. And also with these tools, we can explore root causes and opportunities for improvements in our models. Now I'm going to talk about privacy and security. As commented before, this kind of models may leak sensitive information or be to attacks such as prone injection or adverse manipulation. At this point, focus on ensuring data privacy, and security audits focus on detecting and addressing vulnerabilities. For example, we can find some auditing tools like ProWar. ProWar refers to a set of strategies, tools, or techniques designed to safeguard the behavior of these kind of models from malicious or unintended. Use a classified models with 6 million parameters that has been training on a large dataset of attacks and prompts found on internet. To test the train model is as easy as going to the repository in Hugging and using it with the free inference API that the platform offers us. Basically, this tool is offers like the capacity to prevent harmful or malicious interactions by filtering, monitoring, and responding to adversarial inputs, ensuring that the model's behavior remains safe, ethical, and aligned with the intended use. We have other tools like Jamawar refers to a security tool or a strategy designed for guarding less language models like MetaJama against potential vulnerabilities and adversarial attacks. This tool offers a robust and adaptable solution to protect LLMs against prone injection and jailbreak attacks by combining different techniques or in filtering, normalization, and monitoring monitoring the input of the user. Essentially, this model employs a multi-layered multiple levels to mitigate the risk of prompt injection and jailbreak attacks using techniques like dynamic input filtering, normalization and contextualization, response policy, and active monitoring and automatic response. To test this model, we can do it with the Hugging Face site. Llama will not only tell us whether the content is safe or not, but will also classify the content into 14 different categories. These categories have been extracted from a taxonomy introduced in the following in this investigation. Finally, I'm going to comment tool for this designed for adversarial attacks, data augmentation, and model robustness testing in natural language processing. Basically, test attack is a framework for testing adversarial attacks using techniques like data augmentation, natural language processing. This tool allows user to test how vulnerable is to adversarial samples and helps to improve this. Using the pre-trained sentiment analysis model, for this case, we'll use the pre-trained BERT model, train it on the EMDB movie reviews dataset, a commonly used dataset for binary sentiment classification. Test attacks provides a variety of attack strategies. For this use case, we'll use the text folded attack, a popular algorithm attack technique that replaces words in the input text with synonyms to fool the model without changing the semantic meaning of the text. Now you can run the attack on a simple input to see how robust the sentiment analysis model is against adversarial sample. After running the attack, you will receive adversarial samples where minor change to the input text have altered the model's prediction. In this case, the model originally predicted positive sentiment for the original text. However, after replacing words like love with like it and thrilled with gripping, the model much incorrectly predict negative sentiment despite the fact that the overall meaning remains positive. Once you have identified weakness in the model's prediction, you can use test attack data augmentation capabilities to retrain the model with adversarial samples to improve its robustness. This step allows you to augment your dataset with adversarial samples and retrain the model, making it more resistant to such attacks. And finally, commenting what the interesting resources that we can find in books. For example, these are the books that have been published in the last year with this topic, and these are specific GitHub resources for with the papers that I've commented. And this is another interesting resources that we can for extend the information provided in this presentation. This is the final of the presentation. I think that can be interesting for developers and security researchers. And that's all. Thank you very much for attendance in the Conf42 language models in 2025. Thank you very much. Bye.